Hello everyone. So from the last few days, I've been starting the reagents class. So in this class mainly we're going to see the impact of reagents in terms of the works. So I need to show you how much the weightage of the reagents chapter is going to take up in the HCU exam or any other exam. So for example, I am taking HCU exam. So this is 2019 paper HCU. So here you can see out of 100 questions, you are going to get 9 questions just from the reagents. From the reagents chapter, you are going to get 9 questions. And if you can see the last few classes, so here you can also find the direct questions which are from the my YouTube videos. So here you can see this particle. So this is what the earlier classes which we discussed regarding the substituted lithium reagents. Okay, substituted lithium reagent which can convert acid chloride to aldehydes. So this is what direct question: substituted lithium hydrates. So if you keep following the reagents chapter and if you can make out the assignments, you are going to definitely get these 9 questions out of 100. So 9 will be the guarantee that's going to get from the reagents. So not only in HCU, any other examination, reagents are very important for the point of view organic weightage as well as the total weightage also. Okay. So here I am going to discuss some more examples which are occurred in the previous exam. So if I start from the starting, so question number 8 is one of the previous question in 2019, which is asking about the reagent system KMnO4. So KMnO4 is a strong oxidizing agent which will convert the double bond into the acid, which will break down the double bond into the acid. So each of the double bond side will get one carboxylic acid. So this is what the reagent specificity of the KMnO4. So here the question is asking about the upon oxidation with the excess KMnO4, it's going to form a formic acid and malonic acid. Malonic acid is the dicarboxylic acid with 3 carbons and acetone. This is what the components that are deriving from the oxidation of one of these compounds. So if it is a double bond which is a tri-substituted like this, so this double bond this side will become ketone, okay, and this side will become acid. So one carbon attached double bond will be going to give carboxylic acid. Two substituted or disubstituted double bond carbon will be going to form ketone. So it is indicating one double bonded disubstituted carbon is present, and this is indicating this carbon, this central carbon attached to two double bonds, and this indicating terminal double bonded carbon. So if I write all together, so or you can estimate by trial and error. So this is what the formic acid, and this is what the ketone form, and this is again formic acid. So here two formic acid which is not matching from the given uh, molecules. So next, if I can see this, it is going to give acetic acid, and this will be going to give oxalic acid, and this will be the acetone. So this is also not possible. This is acetone, and this is ketone with carboxylic acid, and this is formic acid. So this is also not possible. So this is formic acid, this is malonic acid, and this is so correct answer will be D. So this question from the oxidation of KMnO4 reagents. Okay, oxidizing reagents. Okay. So in the next question. So 17. So this question number 17 is also from the reagents topic. So here it is asking for the appropriate reagent, most appropriate reagent for the conversion of this compound into this. So if you can observe, this is a C double bond OH that is converted into CH2OH. So carboxylic acid converted into the alcohol but not ester. So best reagent for the conversion of carboxylic acid is boron reagents. Okay, so boron reagent. So in the next class we're going to see the boron reagents. So far we are discussing the substituted boron reagents. So in that you're going to see this boron in THF, which is the best reagent for the conversion of carboxylic acid into alcohol. So for the reduction of carboxylic acid, we are going to use boron. Okay, so this is what. So how can we see the conversion of carboxylic acid into alcohol and this formation of this compound? So if I write the mechanism, so boron is going to convert only carboxylic acid into alcohol. That has done with the usage of boron THF, and after this ester will be there. If I can elaborate ester, so this alcohol can act as a nucleophile, so it will be eliminated. So finally it's going to form cyclic ester. This is what the compound. Okay, this is what the mechanism. Next. Question number 27. This is from the oxidizing agents. Okay, oxidizing agents. So which is a periodic acid. Okay, periodic acid. So periodic acid is used for the oxidative cleavage of the vicinal hydroxides or glycols. So it will cleave the dihydroxy compound into two aldehydes. So initially with the usage of water, ester will be opened to form dihydroxy compound. Then with the usage of HiO4, that is what periodic acid, this will be going to form two aldehyde groups. So this is what the final compound, which is B. So if you know the reagent systems, you can automatically apply and convert into the product. Next. Next reagent system, bromine attack in the non-polar solvents. Okay, bromination in non-polar solvents. So this is above the plane, and bromine will attack at the double bond. Bromine attachment will detect the double bond and saturation. So during the addition of the bromine, so this above the plane group will hinder the attack of the bromine, so that it will attack from the below side, okay, or from the bottom side. and as soon as it is going to form a carbocation, sorry, yeah, this is going to attack it by the bromine plus. So as soon as it is going to form carbocation, okay, so movements lone base will attack onto the carbocation and it is going to stabilize in the process of neighboring group participation. So this will stabilize, resulting into the cyclic bromonium ion. That will be most stable form of the bromination state. Okay. So after the cyclic bromonium ion formation, this OH will act as a nucleophile and attack at the upper side because it is attached from the top side. So from the upper side it's going to attack and it's going to form. So as the group that is present earlier is a above the plane group, so it will attack from the above the plane and bromine will be going to direct to the below the plane. So this is what the molecule that is going to generate. I think which is option A. Okay. So each reagent is specific in terms of stereospecificity as well as the reactivity. So you must know the reagent systems so that you can answer. Next. So next, it is based on the dehydration reactions. So here, resorcinol is given, which is a dihydroxy compound with meta, and X we don't know, and concentrated H2SO4. So concentrated H2SO4 is used for the dehydration, and which is going to in a mixture of NaOH. So that is going to support. So to give greenish yellow color. So indicating that it is a fluorescent. It is going to give fluorescent color. Greenish yellow is fluorescent color. With the usage of these all combination, phthalic anhydride is the system which can form fluoroglycinol. Okay, fluorescein or fluoroglycinol. So with the phthalic anhydride, you are going to get fluorescent compound. So here I can show the reaction. So this is what the reaction. So 2 moles of resorcinol is used for with the phthalic anhydride, which will convert the fluorescein. Okay, convert into the fluorescein. So here dehydration of 2 hydroxy groups are going to happen. At the same time, this hydrogen is this oxygen with the 2 hydrogens of this benzene is also eliminated. So 2 moles of H2O is going to eliminated in presence of concentrated H2SO4 and NaOH. So fluorescent is the compound which will glow in with the fluorescent. Okay, that is what greenish yellow is. Next. So the reagent which is used for the Gabriel synthesis. Gabriel synthesis is used for the formation of amines and amino acids. Using potassium thalamide. Potassium thalamide. So if I can show you the specific reaction. This is what the Gabriel synthesis, where potassium thalamide is used in the presence of base to react with the alkyl halide to form amides, to form alkyl amides. Okay, this upon breaking or hydrolysis is going to give R minus. Okay, so amides are going to form. Next. So one more question from the reagents part. So it is trifluoroacetic anhydride which is dehydrating. Generally anhydrides are dehydrating type, and this importance of this is cyclization also. Cyclization and dehydrating agent. So water will be going to eliminate H and OH from this. It is hydrogen from this OH. So after the H2 elimination, it is going to form cyclic product, which is this. Why it is going to happen at ortho position is, so if you take this is also ortho to O-methyl, it is also ortho to methoxy. So ortho positions of the methoxy is electron excess system where electrophilic attack will be going to happen. Okay, so that is what the reason to give option C. Next. So this is what we discussed. Substituted lithium reagents which are very specific for the conversion of acid halides to aldehydes. If you keep holding the grip of the reagents, you can directly convert or you can directly answer these questions, which are very important for the all PG entrance examinations. Next, reagent used for a brown ring test. So for that H2SO4 and FeSO4, ferrous sulfate and concentrated H2SO4 is used. Okay, for brown ring test for nitrate ion. Okay. So I hope these are the 9 questions that are from the reagents topic. Not only direct questions, many indirect questions which are related for the reagents and neighbor reaction will be going to appear in the examination repeatedly. So if you can see, this is the one of the indirect question of the reagent system HNO2, or you can say intermediate part, or you can say neighbor reaction. So everywhere it's going to interlink. If you get the grip on the reagent, you're going to get every question to the understandable level, then you can attempt easily. So that's all. Thank you.